Hi, I'm Marcus, and I'm working my way learning Rust by going through the Project Euler problems. Today we're doing Euler number 3, largest prime factor. So the problem, the prime factors of 13,195 is 5, 7, 13, 29, so largest prime factor would be 29, so find the largest prime factor of that. Alright, let's dive in. Alright, let's init our project. Source main, and let's get our instructions, the problem, and Euler number 3, and what are we going to do? We need to find the largest prime factors. We need to find all the primes that could be factors of that. So we'll make a function to find primes, and we'll be up to a number. This number looks rather large, but I think it's not going to be too large. What's that look like? I should start the other way, but it looks like it's all, 600 billion. That's fine for our ints. You can find the, I was worried about the max int size, Rust max int size. I don't have all these things memorized. So U32, what is that? Would not be big enough, right? That's only 4 billion, so we need to use a U64 probably. Some of the Euler problems have they'll use very large numbers, and so you aren't able to you have to use a larger type to be able to store that number. Find primes, and we're going to return an array of primes. Sounds good. And then we also want to we'll do something there, and we'll also want to, let's just write a function to do our largest factor, and then we can write a test to test for it. And this is going to return a single number. So our test will be function test largest factor, and we're going to assert what they gave us. We're going to assert the largest factor of 13195 is 29. And I think that should do it. So right now if we return 29, and here let's return nothing, we should be able to run our test. That doesn't like that. I think if I did a vector like this, maybe that will work. Run our test. We didn't use that, we didn't use that, we didn't use that, but our test ran, so we have a working program. Let's make it actually a valid program. And to find our primes, so to find primes, we just want to find all the numbers that are not divisible by previous primes. It's kind of the easiest way mentally to do it. You can use there's a sieve of Aristoteles that will, it's maybe a little more efficient way to do it, but this is a little bit easier mentally. So we're going to create a vector. Let's seed it with a couple of primes that we know, and then we're going to loop through all of our numbers. This is going to be the number we're going to check, and we'll start at 7 because that's the next prime, and go up to, we don't have to, we can go up to num, but we don't have to do that. We can go up to the square root of num, something like that. I'm not sure if this will work. We'll have to look this up. I don't think that's a valid function. We'll look it up. And this you can check the, this is also proved the sieve of Aristotelianis, something like that. I think I had it in my browser over here. Yeah. So you can see he proves there. We only have to go to the square root because if you multiply something else, it makes sense. Trust it. So I check our number. Let's start off and assume it is prime, and then if it's divisible by all the other primes, if the number is divisible by a prime before it, then it's a composite. It's not a prime. So is prime is false. And if we get through all of that, and here, and then if it's prime, let's push it onto our stack. And then we continue. I think we're gonna have to, I'm gonna have a couple of mistakes here, but let's see if that, and here, let's return primes. Let's see what our compiler tells us we did wrong. All right, square root's not found. I think this has to be a, I think square root only works on something like that. So we want to cast this as a, treat this number as if it's F64 type, and then I think square root works on that. Yep. But now that is an F64, so we can do this reverse as U64, and I think that should do it. All right, that's fine. Largest factor, we're not doing anything there yet. Then value moved. So Rust, there's a lot about Rust borrowing and functions. Basically, it doesn't want you to use a variable. I use it again here, so we want to borrow it there. So we don't copy the value or don't change the value here, because then this would own the value. We just want this to borrow it for a second, and then it can be changed there and then reset. Let's try that. And it works. So I think this is still not being used, but let's figure out why that, because we didn't do anything up there. All right. And then find primes, the function is not actually used either, but everything's still compiling. I think that's working. So we should be able to now let's get some primes equal to find primes and num. That's going to give us a vector of primes. We can, I just want to see what they look like, so let's print them out. And if num modulo prime, because now this will have a factor, so we want it equal to 0, so these are going to be our factors. Let's just print it out to see what it looks like. Factor, that is a prime factor. And then if we say max, we'll set max factor equal to 0, and then all we really have to do is set it, because we'll just we'll set it here, right? And then at the end of our show, we will return it. This is in loop through all primes. If it's a factor, we just set it. The last one would be the maximum one, and that should do it. Run our test. Everything passed. It's valid, and we can actually run the program, and we should see no results. Did we not print? Factor if num prime equals 0, it's divisible. Print the factor. Oh, I don't call my function. That might help. Let's call let QED equals largest factor. Would help to call the function you're running, and then what we were trying to show. Let's try that. That was my test. Sorry. Run the build, and there we go. 3, 5, 7, 13, 29, and then the answer is 29. Let's remove output, and let's try another number. I'll leave the actual number to you, our intrepid listener, to solve. Let's just try that, and hopefully I didn't type in a prime. And we'll try and find all the primes below that. It'll take a second. And the answer would be the largest prime factor of that number is 3319. There we go. And that is Euler number 3. Thanks so much.